Hello, good morning, everyone. Today, we'll discuss about some preparations and chemical properties of ethers. Okay. Now, one reaction is there in phenols. There's a coal-based reaction. We'll discuss now first. Thereafter, we'll go for the preparations and chemical properties of ethers. Okay. Right. So, coal-based reaction. See, actually, in this reaction, we are going to prepare the salicylic acid. What is that? Salicylic acid. Now here, phenol reaction with the sodium hydroxide. Phenol reaction with the sodium hydroxide. So then what happened here? From here, H from your OH, water molecules eliminate. Then formation of ONA. Sodium phenoxide it will be formed. What is this? This is the phenol. Phenol reaction with sodium hydroxide. Then water molecule eliminate. Then formation of sodium phenoxide ion. Okay, sodium phenoxide ion. This sodium phenoxide ion is a reaction with carbon dioxide. Okay, sodium phenoxide is reaction with the carbon dioxide. 6 to 7 atmosphere pressure. 6 to 7 atmosphere pressure. So here what happened? These 5 bonds is attract the carbon dioxide. Then the bond shift here. So then the product is O minus H C double bond O minus it will be formed. Okay, right. So now here what happened? This carbon get positive charge. Here one simple mechanism takes place, that is undergoes tautomerism. Okay, right. This bond attack the proton, the bond here. Then your answer is that OH C double bond O minus Na plus it will be formed. This is the product is very important for competitive level. What is the name of this? This is sodium salicylate. Sodium salicylate. Okay. This sodium salicylate furtherly undergoes hydrolysis. Okay. Then formation of salicylic acid. Then formation of plus NaOH as is will be come outside. What is forming here? Salicylic acid it will be formed. Salicylic acid. Okay. So this salicylic acid where it is present in? It's a Zendu bond. It is present in Zendu bond. Okay. So this is the coal-based reaction. Phenol reaction with the sodium hydroxide, then formation of sodium phenoxide. This is a further reaction with the carbon dioxide, gas 6 to 7 atmosphere pressure, then formation of sodium salicylate, which is further undergoes hydrolysis, then formation of salicylic acid. Salicylic acid. Okay, right. Okay, now see this salicylic acid. This is the salicylic acid reaction with the acetic anhydride. What is this? This is a salicylic acid reaction with the acetic anhydride. Acetic anhydride. In the presence of concentrated H2SO4. In the presence of concentrated H2SO4. Okay. So now you see here the bond cleavage from phenolic group. From phenolic group, this proton is attached to oxygen, then formation of, you see, on benzene O, remaining C double bond O CH3, this group is attached to oxygen. C double bond O CH3, okay, plus remaining byproduct. Remaining byproduct, acetic acid will be formed. Acetic acid will be formed. So what is the product name? You know, this is aspirin. Aspirin. Okay. So this is also called acetyl salicylic acid. Acetyl salicylic acid. This is also called acetyl salicylic acid. So salicylic acid reaction with acetic anhydride in the presence of concentrated H2SO4, then formation of aspirin. Okay, or acetyl salicylic acid. Okay, right. Next, so then now we'll go for the preparation of ethers. Preparation of ethers. Now see, in this preparation of ethers, first one from alcohols. From alcohols. See, CH3, CH2OH, ethyl alcohol. I have taken here 2 moles. Ethyl alcohol reaction with the concentrated H2SO4 at 140 degrees Celsius, that is 433 Kelvin temperature. Ethyl alcohol reaction with the concentrated H2SO4, 140 degrees Celsius or 413 Kelvin temperature. So then you see from here OH, from H, water molecule is eliminated, then formation of ether plus water. Ether plus water. So this is ethoxyethane. What is it? You know, ethoxyethane. This is IUPAC name. Common name diethyl ether. So diethyl ether will be found. So you remember, ethyl alcohols are reaction with the concentrated H2SO4, which is depend upon the temperature condition. That point you have to remember. For example, see, tomorrow they will ask a question like this. How you know? CH3, CH2OH, ethyl alcohol reaction with the concentrated H2SO4 at 170 degrees Celsius are 443 Kelvin temperature. See, 443 Kelvin temperature. 170 degrees Celsius are 443 Kelvin temperature. Then formation of ethene. So, same alcohol, if they are mentioned, concentrated H2SO4 at 140 degrees Celsius are 413 Kelvin temperature. 140 degrees Celsius are 413 Kelvin temperature. Then here you get ether. So the number of moles they won't mention here. For ether or alcohol, they won't mention number of moles. So by the temperature only you can identify. See, ethyl alcohol reaction with the constant H2SO for 170 degrees Celsius. Answer ethene. Ethyl alcohol reaction with the constant H2SO for at 140 degrees Celsius. Answer ethane. Okay. So this is the reactions are depend upon the temperature conditions. So these are the important ones. Okay. Right. So now see here. Now we'll see the another one preparation of ethers. That is a very important. That is second one. Williamson ether synthesis reaction. What is that? No, Williamson ether synthesis reaction. Actually, Williamson synthesis reaction, ether synthesis is there as well as alcohol synthesis also is there. So now we are going to discuss about the only ether synthesis only. So now see here, RCl reaction with sodium R, then formation of R plus NaCl. For theory, they will ask compulsory. What is Williamson ether synthesis reaction? They will ask you. Remember this. What is Williamson ether synthesis reaction? They will ask. Now see what you write. Alkyl halides reaction with the sodium alkoxide. Okay. Sodium alkoxide. Then formation of ethers is known as Williamson ether synthesis reaction. See, by seeing the reaction, we can say alkyl halide reaction with sodium alpha oxide. Okay, reaction with sodium alkoxide, then formation of ether. So this reaction is known as Williamson ether synthesis reaction. Okay, so for the Williamson synthesis reaction, some important reactions are there. For some examples also we'll discuss now. Okay, right. Now here I am taking CH3CH2Cl ethyl chloride is reaction with the sodium ethoxide. Ethyl chloride reaction with the sodium ethoxide. Then you remove NaCl. So then formation of CH3CH2O CH2CH3 plus NaCl. So what is the product is formed? Diethyl ether or ethoxy ether will be formed. Diethyl ether will be formed. Okay. So one important point to remember for the quantitative level. This is a very important point. Williamson synthesis reaction undergoes SN2 mechanism only. Williamson ether synthesis reaction undergoes SN2 mechanism only. Okay, right. Now see, we'll discuss now the important point is that For example, if you take methyl bromide is reaction with NaO, CH3. Sodium alkoxide is a tertiary alkoxide, but methyl bromide is primary one only. So methyl bromide only. Okay. So now see here. So here this reaction is undergoes Williamson synthesis reaction or not means compulsory undergoes Williamson synthesis reaction. Why? Because the reactivity order of alkyl halide, methyl bromide, primary, secondary, tertiary are there. Compulsory undergoes Williamson. Methyl only is there. So here compulsory undergoes what is that? Williamson ether synthesis reaction. So then now you take here NaBr, then you get answer is that CH3O, CH3. So this is the product is formed. Then plus NaBr. This is the product. It will be formed. See what is the name of compound? See 1, 2, 3, 2-methyl methoxy, 2-methoxy propane. This is the product. It will be formed. So this also comes under Williamson ether synthesis reaction only. Okay, but the condition is that CH3. See, this is the reaction, but the condition is that tertiary butyl bromide to tertiary butyl bromide reaction to sodium methoxide. So is this undergoes a Williamson synthesis reaction means already I told you it is not undergoes. Which is not undergoes. Why? Because Williamson ether synthesis reaction follow the SN2 mechanism only. Williamson ether synthesis reaction follow SN2 mechanism only. According to SN2 mechanism, the reactivity order of alkyl halide, methyl bromide greater than, primary greater than, secondary greater than, tertiary. Methyl bromide greater than, primary greater than, secondary greater than, tertiary. So remember, this is the point. Okay, what is the point? So that's why here tertiary butyl bromide is reaction to sodium methoxide. So here this is not undergoes Williamson ether synthesis reaction. So then what is undergoes? Actually, what is the reaction takes place? Now see, the reaction is that elimination reactions takes place. What is that? Elimination reactions takes place. We remove from NaBr, from this proton is attracted by the oxygen, and it bonds to here. So then what is the product? CH3 double bond CH2 plus NaBr plus methanol will be formed. So what is the product is formed? 2-methyl propene will be formed. 2-methyl propene will be formed. What is the product? 2-methyl propene is a product is formed. Okay. So, sir, why is there? How can you say Williamson ether synthesis reaction undergoes SN2 mechanism only? Okay. Now you remember one point. Sodium alkoxide is the very powerful nucleophile. Sodium alkoxide is the very powerful nucleophile. So if alkyl halides are primary are there, those are undergo substitution reaction. If alkyl halides are tertiary are there, so this is the elimination reaction takes place. Elimination reaction takes place. So whatever the reaction I have written now, this is not a Williamson ether synthesis reaction. It is a elimination reaction. You remember, this is not comes under Williamson ether synthesis reaction. Okay. So one doubt. By using Williamson ether synthesis reaction, we are unable to prepare aromatic ethers. Aromatic ethers. Yes, we can prepare. Now see, one example here I am going to take. So this is the phenol reaction with sodium hydroxide. Phenol reaction with sodium hydroxide. What is the product is found in? Sodium phenoxide. From here, from the OH. So water molecule is eliminated. Then formation of sodium phenoxide. Sodium phenoxide is formed. Sodium phenoxide. Sodium phenoxide will be formed. This sodium phenoxide, okay, reaction with the methyl iodide. See, methyl iodide. Sodium phenoxide reaction with methyl iodide. So then you are going to say aromatic ethers only. Then you remove NEI. Remove NEI minus NEI. Okay. So then what is the product is formed? Unbenzene OCH3 will be formed. What is formed? Unbenzene OCH3 will be formed. Methoxybenzene. What we call methoxybenzene. Methoxybenzene. Another name very important. This is called anisole. Anisole. So same like this. Another preparation also we will discuss now. Same. For example, sodium phenoxide. Say sodium phenoxide is reaction with the ethyl bromide, for example, ethyl bromide I have taken. So if you take an ethyl bromide, so any value will be eliminated from here, then what is the product is formed now? Unbenzene OCH2 CH3 will be formed. Then byproduct NABR will be formed. Byproduct NABR. So this is also how the special name you remember ethoxybenzene. Ether 2 carbon ethoxybenzene. Okay. Otherwise, it is called the important name you remember phenetole. 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 Okay. Just to remember this. Okay, so these are the aromatic ether preparations, right? See, next now see, we'll see the chemical properties of ethers. What is that? Chemical properties of ethers. Especially, you remember the chemical properties of ethers. Okay. Now see the reaction with HI, hydrogen iodide. Now see, here I am going to take one important reaction. CH3CH2O, CH2CH3. These are the symmetrical ether. When oxygen left side, right side, same number of carbons are there. Symmetrical ether, which is reaction with the HI. So in a cold condition, where it is the cold condition. Cold means you remember this is the 1 mole of HI. So now what happens? See, if you break the bond here, the carbon get positive charge, oxygen get minus charge from H plus and I minus. So now what happened? This iodine is attached to carbon and hydrogen is attached to oxygen. So then formation of here two products are found. One is ethyl iodide plus another one ethyl alcohol. These are the two products are found. One is the ethyl iodide plus another one ethyl alcohol. These are the two products that will be found. Okay, so this is the reaction with the HF. Right. Now we'll see the reaction. CH3 CH2O CH2CH3 plus HI in the presence of hot condition. Same symmetrical ether. Here I have taken cold condition, here hot condition. Hot condition means you remember here two moles are involved. Excess they will take, otherwise 2 moles are they will take. So hot condition for the excess are they will take 2 moles. So here what is the reaction takes place? 2 moles of hydrogen iodide I am taking like this. 2 moles of HI. So then here you remove the water molecule. So then what happened? You get CH3CH2I, CH3CH2I. CH3CH2I, 2 moles will be found, plus water molecule will be eliminated. Water molecule will be eliminated. You remember. So this two type of condition. Cold condition means two products are found, that is we're taking one HI. So what is ethyl iodide and ethyl alcohol. Hot condition means excess of HI involved, that is one product only formed, that is ethyl iodide only. These two reactions were only symmetrical ethers. What is the meaning of symmetrical ethers here? Oxygen on the left side, right side, same number of carbons are there. Those are called symmetrical ethers. So for a different unsymmetrical ethers are there. Unsymmetrical ethers are there. Then what will do, sir? See here, I am going to take the unsymmetrical ethers. So here CH3, CH2O, CH3, CH3, CH2, CH3O, CH3, 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 CH3O, CH3. So, like this, actually, 3 ethers I have taken. These are also unsymmetrical ethers you see. Oxygen right side methyl, left side ethyl. Oxygen right side methyl, left side isoprotoxy. Oxygen right side methyl, left side tertiary tertiary butyl group is there. So these 3 are unsymmetrical ethers. So for the 3 conditions, if I take HI, here also HI, here also HI. So then what happens here? The unsymmetrical means a doubt it will become. Hydrogen is attached to small alkyl group or large alkyl group. Or iodine is attached to small alkyl group or large alkyl group. Why? Because oxygen left side do large, small. Oxygen left side do large, small. Oxygen left side do large, and methyl is the small alkyl groups are present. So now you remember the important technique. You remember the point is that for primary comma secondary ethers, iodine is attaches small alkyl group only. Iodine attaches small alkyl group only. What happened? Iodine is attaches small alkyl group only. Okay. So now see, there is no confusion at all. You remember this technique. This iodine is attached to small alkyl group. Hydrogen is attached to oxygen. Then formation of CH3CH2OH plus methyl iodide. Because so these are the primary alcohols. The secondary alcohol also reaction with HI. So iodine is attached to small alkyl group only. Then formation of isopropyl alcohol plus CH3I. Okay, right. Now, if you comes up to tertiary, you remember. So what happened now? If you take tertiary alkyl group, if you are taken, then what happened now? This iodine group is attached to the large alkyl group. Large alkyl group, hydrogen is attached to small. So why? Because the CH3 plus CH3OH methanol will be formed. So here iodine is attached to big alkyl group where in tertiary condition. In tertiary condition, iodine is attached to big alkyl group. Tertiary butyl iodide is formed. Tertiary butyl iodide will be formed. Why? Because which is follow the SN1 mechanism, and these two follow the SN2 mechanism. You remember that is a point. Okay, right. So one question every year asking for the competitive level. So that is also we see now. Now see here, I am taking here anisole. Anisole reaction with HI. And phenetole also reaction with HI. And another one is that you see CH2O CH3. So this is also reaction with HI. The last final one is that now see if these are the reaction with HI, then what are the products are formed? We'll discuss now. Okay. So here also oxygen left side iron big one and small one. You remember this also primary alkyl, but iodine is attached to methyl group only. Then the answer is that phenol plus methyl iodide. Phenol plus methyl iodide. Now see here. Here also iodine group is attached to small one only. So then formation of here phenol plus methyl iodide will be formed. And so this is important for competitive level. You remember which is follow the SN1 mechanism. So here benzyl carbocation is formed bond break here. Benzyl carbocation is the more stable. So that's why iodine is attached to benzyl carbocation. So then formation of benzyl iodide CH2I plus methanol will be formed. And last finally you remember this is the reaction is very important. This is aromatic ethers. Both sides of aromatic group is there. So these are does not reaction with HI. Why? Because oxygen group directly attaches to the sp2 hybridized carbon. You know that from the sp2 hybridized carbon they are unable to break the bond. So that's why these ethers are aromatic ethers are. Okay. Otherwise we can call what is the name? Diphenyl ether. Diphenyl ethers are does not react with HI. You remember this is the important point. Okay, right. See. Now we'll see some electrophilic substitution reaction of aromatic ethers or anisole. Electrophilic substitution reaction of anisole. Okay. Now see here I am going to take anisole and benzene OCS3. This is anisole. Anisole reaction with Br2 in the presence of protic solvent like CH3C double bond OH. So here orthobromoanisole and parabromoanisole it will be formed. Orthobromoanisole plus parabromoanisole it will be formed. What is that? Orthobromoanisole and para-bromoanisole it will be formed. Ortho-bromoanisole and para-bromoanisole it will be formed. Okay, so this is halogenation reaction of first one. What is this? This is halogenation reaction. Halogenation reaction. Right. Next, the anisole will discuss about the Friedel-Crafts alkylation reaction. Friedel-Crafts alkylation reaction. See, same this anisole OCH3 reaction with methyl chloride. Methyl chloride in the presence of anhydrous AlCl3. In the presence of anhydrous AlCl3, then what happened? 2-methyl anisole plus 4-methyl anisole it will be found. 2-methyl anisole, 2-methyl anisole and 4-methyl anisole it will be found. 4-methyl anisole it will be found. So this is Friedel-Crafts alkylation reaction. Anisole reaction with methyl chloride in the presence of anhydrous AlCl3. So these are the products are found. Next we will see the electrophilic substitution reaction. Friedel-Crafts acylation and nitration reactions to discuss now. What is that? Friedel-Crafts acylation reaction. Friedel-Crafts acylation reactions takes place. Now see here, same anisole OCH3 reaction with acyl chloride or ethanol chloride or acetyl chloride. So this is reaction with in the presence of anhydrous AlCl3, then formation of 2-methoxyacetophenone. So in this 2 function group, acetophenone ketone function group is the highest priority. For this function group, you have to give the number 1. Number 2, 2-methoxyacetophenone will be found. Okay, so as well as para position also will be attached. Then formation of 1, 2, 3, 4. 4-methoxyacetophenone also found. 4-methoxyacetophenone also found. So anisole reaction with the acetyl chloride in the presence of anhydrous AlCl3, then formation of 2-methoxyacetophenone as well as 4-methoxyacetophenone it will be found. And last final we discuss about the fourth one is the nitration reaction. Nitration reaction. Now see, same this anisole reaction with concentrated H2SO4 plus concentrated HNO3, see, then formation of orthonitrophenol plus para-nitrophenol. Orthonitrophenol plus para-nitrophenol. This is the product that will be formed. So these are the chemical properties of ethers, preparations and ethers completed in alcohol, phenols, ether. These 3 alcohol phenol ethers and alkyl halide. These 2 chapters completed in the second year organic. Then next class, tomorrow we'll discuss about the aldehydes and ketones and carboxylic acid. This is we'll discuss now. Okay. Thank you very much. Bye.